Okay, so in this video we're going to be talking about limits at infinity and negative infinity. The example your professor probably showed you to introduce this idea was a limit as x tends to infinity of 1 over x. Well, we're going to make things a little bit spicier here, and we're going to look at the limit as x tends to infinity of 1 over x plus 2. Hopefully you remember that when you have some function plus a constant, that's just that function translated 2 units, or well, the number of units, or well, if you have a function plus the constant 2, the graph of that is just the function translated 2 units upward on the y-axis. So here. So I'm just going to go ahead and draw it and then explain why it looks the way it looks. Okay, so this is basically the same as the graph of f of x equals 1 over x. The only thing is it's translated 2 units upward. And to convince yourself of that, you just plug in points. So say we plugged in 1. What we're going to get for x, then we're going to get f of x is 3. Right, here's the origin. So 1, 3 is here. Say we plugged in really small fraction. Well, then this is going to be a really big number. We're going to add 2 to that, so you'll have 2 more than a really big number, which is an even bigger number. And as you plug in smaller and smaller fractions, you're going to get bigger and bigger numbers for 1 over x, and then you add 2 to them, those numbers are only going to get even bigger. Now let's say we wanted to plug in a really huge value for x. 1 over a really huge value is a really small value, and you add 2 to that really small value, you get a value that's very close to 2 but a little more than it. Now when we look at negative values of x, let's say we plugged in a really small negative fraction, well then x is going to be a really large negative number. We add 2 to that, it'll be a slightly less negative but still large negative number. We plug in x is equal to negative 1. This will be 1 over x would be negative 1, but we add 2 to that, so we get positive 1. When we plug in really large negative numbers for x, we're going to get really small numbers for 1 over x, really small but negative numbers, and we add 2 to them, we're going to get numbers very close to 2 but slightly less than 2. And so you can tell there is a horizontal asymptote at y equals 2 and a vertical asymptote at x equals 0. But this limit as x tends to infinity of 1 over x plus 2 is 2 because as x gets bigger and bigger and bigger, y, or f of x, gets closer and closer to 2. And in general, the limit as x tends to infinity or negative infinity is going to be a horizontal asymptote for the function. So as x tends to, if we wanted to see the limit as x tends to negative infinity of 1 over x plus 2, that's also going to be 2 as x if you want, as x gets bigger and bigger in the negative direction, 1 over x plus 2 gets closer and closer to 2. Still remains underneath 2, less than 2, but approaches 2, but never quite touches it. But in the limit, this is equal to 2, as is the limit as x tends to infinity of 1 over x plus 2. So that's our first example. I'll just say example 1. That looks more like a 7, but hopefully you can tell it's a 1. Next example we'll look at is the limit as x tends to negative infinity of e to the x. So first just going to draw the graph of e to the x. Well, what's e to the 0? Well, e is about 2.718, and anything to the 0 is 1, so we know 0, 1's on the graph. E to the 1 is just under 3. It's e. E's 2.718. E to the 2 is going to be 2.718 squared, so 8 point something. And if you plug in bigger and bigger values of x, say you took e to the 10, you're just going to get a massive number. So you can see that this is going to grow exponentially. Now what happens for negative values of x? Well, if we looked at e to the negative 1, that's 1 divided by e, which is going to be, e is 2.718, so you have somewhere between 1/2 and 1/3. If we e to the negative 2, it's going to be 1 divided by e squared, so you're going to get an even smaller fraction. And if you took e to the negative 10,000, you get 1 over e to the 10,000, which is 1 over a massive number, and 1 over a massive number is a positive number really close to 0. So this is basically how the graph looks, and as x gets to be larger and larger negative numbers, e to the x is going to get closer and closer to 0. So the limit as x tends to negative infinity of e to the x is 0. Now we're going to consider a similar limit here. It's the limit as x tends to infinity of e to the negative x. Now you remember e to the negative x is 1 over e to the x. So just looking at the graph above, how do you think it'll look? Well, basically we're going to take every y value, we're going to be taking the reciprocal of here. This is e to the x, this is e to the negative x, or 1 over e to the x. So this is the same thing as the limit as x tends to infinity. I don't know why I can't draw infinity today. Of 1 over e to the x. So until x equals 0, for e to the x you have really small fractions. So the reciprocal of a really small fraction is a really big number. And as the fractions get closer and closer to 1, like let's say we took the reciprocal of 1/2, well that'll be 2. Let's say we take the reciprocal of 1/9, well that'll be 9. right? So we're going to get smaller and smaller, but still numbers bigger than 1. And we will hit 1 when x equals 0. The reciprocal of 1 over 1 is 0. E to the 0 is 1, and so 1 over e to the 0 is 1 over 1, which is 1. And now when we're looking for positive values of x, we're going to be taking the reciprocal of larger and larger numbers. So 1 over, say 1 over 9 is going to be 1/9. E squared is a bit smaller than 9. But we'll have a number like 1/9 here. But e to the, say we looked at e to the 10,000, that will be a really big number. 1 over e to the 10,000 would be a really small number, really close to 0. So this just gets closer and closer to 0, like so. You can see for larger and larger values of x, e to the negative x gets closer and closer to 0. So the limit as x tends to infinity of e to the negative x is equal to 0. And we're going to take a look at another example. It's the limit as x tends to infinity of sine of x. So hopefully you'll remember from pre-calculus that sine of x looks kind of like this. So this is pi over 2 pi, 3 pi over 2, 2 pi, and we'll let it continue on. Negative pi over 2. Just go ahead and draw some more values here. 2 pi. And this is 1. This is negative 1. And as you continue, it'll basically repeat in this pattern. So then we have to ask ourselves, what's the limit as x tends to infinity? As you get to really large and large numbers, does the sine of x approach any particular value? Well, like we just said, it basically continues like this. And so it'll always be trapped between -1 and 1, but it'll really never approach any value. It will only be oscillating between -1 and 1 in this fashion here. So we say the limit as x tends to infinity of sine of x does not exist. There is no limit. There is no value that this function approaches as x approaches larger and larger, as x becomes larger and larger. And sometimes in math they abbreviate does not exist as D and E. Okay, we'll look at a couple more examples, but before I continue, I have to mention one thing. The rules for algebraically evaluating limits as x approaches infinity are identical for those as x approaches a particular value. So all the properties we looked at a few videos ago, those apply for limits at infinity as well. So I'll just say rules for finding limits as x tends to infinity or negative infinity are same as for x tends to a, where a is a constant. I'll just say where a is a number. So knowing that, let's make use of that in a couple of examples. Here's one. So the example we looked at, the first example we looked at was the limit as x tends to infinity of 1 over x plus 2, and we looked at this graphically. But algebraically, we now know that that's the same thing as the limit as x tends to infinity of 1 over x plus the limit as x tends to infinity of 2. So what's this limit here? Well, as we plug in bigger and bigger values of x, say we plugged in 10, we'd get 1/10. We plug in 100, we'll get 1 divided by 100. We plug in 10 billion, we'll get a really, really small number. So it looks as x gets bigger and bigger, 1 over x approaches 0. And what's the limit as x tends to infinity of 2? Well, hopefully you'll recall from our properties video that the limit as x tends to anything of a constant is that constant itself, because this f of x equals 2 is just a horizontal line, regardless of whether you're talking about really big negative values, really big positive values, or somewhere in between. The function is still equivalent to 2. So 0 plus 2 is 2, and that limit is 2. Look at one more here. And that's the limit as x tends to negative infinity of 1 over of 1 plus e to the x, the quantity squared. Okay, so you remember that the limit as x tends to a number of something squared is the limit as x tends to that number of that something. And infinity, negative infinity are not numbers, but the rules for them, for limits as x tends to either infinity or negative infinity, are just analogous to those for which x tends to a number. So that's this limit here. That's really the square of this limit here. Okay, and this limit is really the limit as x tends to infinity minus infinity of 1 plus the limit as x tends to minus infinity of e to the x. But the limit as x tends to minus infinity of 1 is just 1. So we can just write it like this. This whole thing squared. And this limit here, if x gets to be larger and larger negative numbers, like e, let's say e to the 10,000, e to the negative 10,000, well, that's going to be 1 over e to the positive 10,000. 1 over a really big number is going to be a really small fraction. And as that number gets bigger and bigger, so you have e to the minus 10 billion, which is 1 over e to the 10 billion. The 1 over e to that number, or e to that opposite of that number, e to the minus of that number, will become closer and closer to 0. So we essentially have 1 plus 0 quantity squared which is just 1. And hopefully that gives you an idea of how to use the limit rules for limits where x is approaching either infinity or negative infinity.